In this video, we are going to learn about the law of sines. Right? This law of sine is used to solve a triangle. Here you see that it is not a right triangle. Actually, a trigonometry in the basics, we always used to have right triangles. The triangles are of this type, like right angle here, hypotenuse and opposite adjacent sides and all that. But if a given triangle is not a right triangle, how do you solve? So in order to do that, we have the first law here, the law of sines. Similarly, you also have the law of cosines. We'll learn about it in another video. So here, a basic triangle, you have triangle ABC. Those are the three angles at those vertices. And opposite to this angle A, you have A, that is the measure of this side BC. And this B is the measure of this side AC, which is opposite to angle B. And the other one is, the last one is a C, right across the opposite to angle C. And it is the length of the side AB. Okay. We are going to find the relationship between these side lengths and the measures of the angles. By finding out the relationship, which is called as the law of sines, we will be able to solve a given triangle. Okay. For that, I need a circle which is passing through all the three vertices A, B and C. And here O is the center of the circle. And now I'll also draw one diameter. It is a line touching, or it is the longest chord, we can say it is the longest chord, that is touching 2 points on the circle and also passing through the center. This point I'll call it as a D, right? D here. So BD is the diameter. And one more line I'll take here. Join A to D. So I need this. Now by drawing this circle around the triangle ABC, of course you call it as a circumcircle, and I have BD as the diameter, and I also joined A to D. Okay. One thing we observe that these two angles, angle D will be equal to angle C, because they are the angles in the same segment of the circle. Alright, I have it here. Let me show you. The angles in the same segment of a circle are congruent. That is, this AB is one chord. This chord AB is dividing the circle into two segments. Okay. Now all these angles, this is first angle, second, third, you can draw many more angles. All those measures will be the same. For example, if you have this measure is 50 degrees, there also the measure of this angle is 50, and the next angle 50 degrees. In other words, we can also say that those are the intercepted angles, or the angles inscribed in the same arc of the circle, and they are all have to be same. Just remember that, because they are on the same part of the circle, they have to be the same. I need that info in order to find the relationship here. Okay. Now, having known that dB is the diameter, and this is a semicircle, half of the circle, and other side half of the circle. So the angle in a semicircle is a right angle, right? This angle is 90 degrees, right? This is a 90 degrees angle. So triangle ABD is a right triangle, right? This triangle ABD is a right triangle. at angle A is equal to 90 degrees. Angle A is 90 degrees. It is a right triangle. Let me bring it here. So I have, this is A, that is a D, and this is B. You know that dB is the diameter. So radius plus radius, that is twice the radius. The length of this dB is 2r. 2 times the radius, 90 degrees I'll put here. Okay. Now I have in this triangle, I'll try to find what is the measure of sine of this D. For this angle D, you know that AB becomes the opposite side. AB is the opposite, and DB is the hypotenuse. The measure of this hypotenuse is 2 times the radius, and the opposite side O, you already have it as C, right? That measure is C. Okay. Now, sine of an angle D is equal to opposite side, which is a C, opposite side is C, over hypotenuse, that is 2r. Alright. Now from this, already we discussed that the angles in the same segment are equal. So angle D is same as angle C. If the measure of angle D is equal to the measure of angle C, so the sine of angle D is also equal to sine of angle C. Whatever is the value of sine D, sine C has to be same because D and C are identical. Therefore, what I can do here is I will replace sine D and I'll just write down sine C because D was introduced whereas C is already there. So I'll get rid of that D. Instead of sine D, I'm writing sine C is equal to this lowercase c over 2r. Alright. Now that becomes, I want to interchange those two, like 2r and sine c. I can just interchange them, or switching them around, we will write 2r is equal to c over, this is lowercase c over sine c, sine of angle C. Right? What I did here is just sine C and 2r. We switch their places. You can do them because it is like it's a product and cross multiplication. You know all that. Just 2r goes here, sine C came down. Right? So in this whole thing, we made use of this D by introducing that diameter and handling it. You got one ratio, C over sine C is equal to 2r. Similarly, you can write here, you can get further simplification, or further you can say 2r will be equal to lowercase a over sine A. We will be able to prove that a over sine A is equal to 2r, and again 2r equal to lowercase b, the length of b over sine b in that triangle. So in all the three ratios, these are like three ratios or equations you can call, we see that the left hand side is 2r, 2r and 2r and 2r. Now if the left hand sides are the same things, those right hand sides have to be equal. That is, a over sine A must be equal to b over sine B, and that is equal to c over sine C. This is nothing but the law of sines. So the law of sines state that a over sine A is equal to b over sine B, and that is equal to c over sine C, where this lowercase a, b and c are the measures of the sides A, B, C, A, B and C, like opposite to this angle you have lowercase a, lowercase b and lowercase c, and this sine A, this angle A, B and C you already have there. Out of those measures, out of those 6 things, like 3 sides and 3 angles, they'll give us 2 sides and 1 angle. Sometimes they even give 2 angles and 1 side. You can find the rest of the angles and the sides. That is, we use this formula to solve a given triangle which is not a right triangle. It is not a right triangle, but having known this, we'll be able to solve. So let us look at one example. Let us solve the triangle ABC if angle A is equal to 35 degrees, angle B is equal to 103 degrees, and the measure of B is 40.6 units. So the formula is A over sine A is equal to B over sine B, and that is equal to C over sine C. So triangle is not given to us, so we can draw one rough diagram of a triangle. So you have triangle A, B and C. Just we are not going by the measures, just a triangle, and then lowercase a, and here the opposite to B you have B, and that is a C. And let us write down those values. For A is 35 degrees, you have 35 degrees. B is 103. Of course, B is an obtuse angle here, but it's just a rough figure. And B 40.6 is the measure of this B. So we have that. Now we are looking for A is equal to how much? What is the measure of C? And this angle C also you are looking for this angle C. Of course, I don't need this law of sines to find the measure of angle C. I don't need it. So just what do? We know that in any triangle, sum of all the 3 angles equal to 180 degrees. That is angle A plus angle B plus angle C is equal to 180 degrees. The measure of A is how much? 35 degrees plus B is equal to 103 degrees plus C is equal to 180. So how much? 35 plus 103 is 138 plus C is equal to 180 degrees. Now to get to C, I'll take away 138. 138 minus 138, that gives you angle C is equal to how much? 42 degrees, I think. Is it right? Yeah. 78, 42 degrees is the measure of angle C. Instead of all these steps, you can directly add those to 35 and 103 is how much? 138. Take away from 180. That's 2 here. 7 minus 3 is 4. 42 degrees. Just, or this is the whole story. Anyway, now you got this angle C also. Angle C is 42. We have now only that the measure of this A and this C. You are looking for the side A and side C. Now I'll use this formula. Let me bring it here and substitute those values. Now A is question mark A over sine A. Your A is not known. A over sine A, that is 35 degrees. A over sine 35 degrees is equal to B, how much? 40.6. 40.6 over sine B. B is how much? 103. 103 degrees, and that is equal to C is also not known. So I'll write C over sine C. Just now we got 42 degrees. Right. Now, in this law of sines, we substitute all the known values and unknown as it is, like A and C. We left them over. Now, we cannot handle all the three ratios at a time. And here, the middle ratio has the values like 40.6, and that is sine 103. That gives you a constant value, a number you get out of this. And use this middle ratio with the first ratio to get the answer for A, and again the middle ratio with the third ratio to get the answer for C. So I'll show you how do you do this. Like I said, I'm using this first. These two I'll use. Okay, so A over sine 35 degrees equal to 40.6 over sine 103 degrees. Now, A is the unknown thing. We are looking for A. So, let us get rid of the denominator sine 35. I can cancel out this sine 35 from the denominator by multiplying with sine 35 on the left hand side. Because I multiply by sine 35 on the left hand side, do the same thing on the right hand side, that is multiply by sine 35. On doing that, I got sine 35 cancelled here. So on the left hand side, you are left with only A. A is equal to 40.6 over sine 103 degrees, 103, sorry, times sine 35. So on the numerator you have these two. Okay, now just take calculator. I have my calculator here. Let us enter these values. I'll start with the parenthesis, or let us use fractions. I'll show you. Go to alpha and y equal to, that gives me a fraction. That's 40.6 times sine 35 degrees. It is in the degree mode. We have seen it before. Yeah, that's in the degree mode. And in the denominator, you have sine 103 degrees. Sine 103, close parenthesis. Hit enter. That gives you 23.899, etc. Okay, so A is equal to 23 point, we'll round it to 1 decimal because that's what they did here in the problem, 40.6. So 23.9 units, whatever the units are, centimeters or inches, whatever you have, that's all right. So that's the value of A. Now just we repeat the same process for finding the value of this C. So now we have this A 23.9. A is also done. Now we are just looking for C. To find the C, I am using the second and third ratio. That is 40.6 over 103. Alright, I'll write here 40.6 divided sine 103 degrees is equal to, you are looking for C over sine C. The C value is 42 degrees. Let us just double check. Yeah, 40.6 over sine 103 is equal to C over sine 42. Okay, now let us just repeat it. Now you are looking for C, so cancel off sine 42. I multiplied this on the right hand side. So same sine 42 multiply on the left hand side, so that this got cancelled. Now we are left with sine 42 times 40.6 over sine 103 degrees is equal to C, the measure of that side C. Okay, let us use calculator again. I'll go to fraction, sine 42, sine 42, close the parenthesis, times 40.6 divide sine 103 degrees, close, hit enter. We got 27.88. Right, let me bring it here. Okay, this is how much? 27.88. I can write it as 27.9 units. So my C is equal to 27.9 units. Right, even C is also done. So let's go back to the triangle. We have A, we have B, now we have that is C, 27.9. C is also 27.9. Angle A, angle B, angle C, everything is done, right? So this is how you solve a triangle. Now you can take one example and try it by yourself. Okay, thank you. Thanks for watching.